Is it started?
Yep, it started. So let's just give it like 30 seconds. Let some people pull in here from Discord.
Perfect.
Cool. Welcome everyone. Really excited to have Dave from the Graph joining us today. We'll give it just a few moments. Let some people join in. Let me share this in our channels. And where are you calling in from today, Dave?
I'm in Toronto, Canada.
Nice. Okay.
Yeah.
Sweet. Welcome. All right. Well, yeah, without further ado, really excited to welcome Dave from the Graph joining us today. Again, if you have questions throughout this, drop them into the YouTube channel. If there's time at the end, we'll be able to answer those. If not, definitely just drop your questions into the Graph section on the Discord, and we'll be able to get to those and help you all with your projects. Otherwise, love seeing all the excitement in the Discord. Really exciting times. And Dave, I'll let you take it away.
Awesome. Thanks a lot, Keenan. So yeah, I'm here today to talk about how you can use the Graph and what the Graph really does, and explain what you could do in the Chainlink Hackathon. I'm sure many of you who will be watching this video, are aware that the Chainlink Hackathon is happening right now as you signed up for it. And there's all these sponsors and all the subscriptions here, and you can find here that the Graph is actually doing a $5,000 prize. And it's actually 5 different prizes of $1,000. And so just to start off describing what those are, the 5 prizes are going to be for 5 different blockchains that could be powering, any blockchain network, such as Ethereum or Phantom or using IPFS as well. Basically anything that the Graph works with. And the types of subgraphs we are looking for, the 5 that are each worth $1,000. One would be just the best new Web3 subgraph, the best NFT subgraph, the best DeFi subgraph, the best governance subgraph, and the best subgraph using Chainlink's oracles. So that's kind of what you can expect to see if you're going to submit a project using the Graph. If you use one of those, you could win a prize as well. If you somehow incorporate both of them, you could also win 2 of those prizes right there for sure, as well as whatever other prizes are going on in this hackathon. I'm sure you're allowed to combine them as well. But that's a little bit of a download of what you can win for this hackathon. And now let's get into the details of what it means to build a subgraph and how you can do it. So if you guys have heard of the Graph before, you can go to the website thegraph.com, and there's a lot of explainers there. You can download in your mind what the Graph is. But today, what we're going to go over is mainly just developing subgraphs. And I'm sure I'll be able to, give a lot of information about what the Graph is overall, but we're going to focus on just developing the subgraphs and writing a little bit of code to show you, to get yourself off the ground with an example that you could use if you're going to build and hack in the hackathon and use the Graph. So what you want to do is go to thegraph.com and then go to docs. And once you're there, you're going to see these 2 sections, the hosted service and the network. And so the network is focused on the mainnet and all the indexing and delegating and actually doing transactions on chain. So we don't have to worry about that for this hackathon. What we want to look at is the hosted service. And so we're going to click into there. And first, I should describe what the hosted service is. So the Graph network is a decentralized network that does basically indexing on top of a bunch of different blockchain networks. And it allows, and it works in a decentralized manner in that there are many different nodes around the world, which we call indexers, that are indexing all the subgraph data and then allowing users to query that data. Now, the network that is live on mainnet right now is still very new, and there's only one subgraph there, and we're not really dealing with that for the hackathon. What we're dealing with is the hosted service and being able to submit a subgraph to the hosted service and see it working, basically. Technically, you could, the subgraph you build for this hackathon could end up on the mainnet in the future. But this is just kind of like, when you're doing a hackathon, you usually gonna hack something together and put it together, hack something together quickly. And the hosted service lets you do that. So quickly, I'm going to leave the docs for a second and go to the Explorer. And this is basically the hosted service. And what it does is it has all of these different subgraphs, which contain a bunch of different blockchain data, and they're available for the community to look at and to use and to explore data from. So if you go to the Uniswap subgraph, you'll see that there's, you know, like some high level information here. And then there's all these different entities on the right side. And this is a GraphQL schema. And then we're actually querying the data from the subgraph right here. And if you press that, you're getting data back from the blockchain. And so this is what, you know, this is what the hosted service is. It's really a playground that allows you to see all this information. It's very rich and like very human readable here, as well as you can query the hosted service directly and get all this information. And you could do thousands or tens of thousands of queries and get, you know, historical data or do some like data analysis for specific prices. And so that's what the hosted service really is. It's a place where anybody can go deploy a, you know, a new subgraph that they want to play around with or get other people to use. And as you can see, these top ones up here, these are all, you know, like featured subgraphs that we want to put up front because they get used a lot and they have a lot of good information. And if you scroll down, there's all the community subgraphs here, which is basically anybody can upload a community subgraph. And, you know, we're going to do an example of that today. And once you're doing that, a subgraph creates an endpoint. So you would essentially, you know, query this URL. And when you query that URL, you're getting back the, you would send in the payload, you know, maybe this specific query, and then you're going to get back this payload from the subgraph. And so that's really what the hosted service is. It allows you to use the graph. It allows you to get any blockchain data, and you know it's a service that we provide, and it's all free, as opposed to like the network itself, the main network, which would obviously cost money to query. But we don't have to get into that today. So you know that's the hosted service. It's this free service that allows you to build subgraphs, deploy them to there, and to actually, you know, start using the graph. And so when we go to docs, we're gonna quickly go to defining a subgraph. So this is gonna get into the details a little bit of what a subgraph actually is and what it does. And then you'll be able to understand what you can do with it in the hackathon. So really a subgraph is you know, it's indexes data from Ethereum, but really we're adding multiple blockchains, you know, every month we're adding new blockchains, and that's the goal of the graph, is to be, you know, blockchain agnostic, to be multi-chain, to include every chain that the community wants, and that's ultimately the goal. And so now you know, that's what a subgraph is supposed to do, is take specific subsets of blockchain data and define them really well so that people can use them. In a sense, it's like a subgraph is an open API that you can rely on to return specific data that you expect to be returned. And so what we've done with the subgraphs is we split them up into three different, you know, there's three different pieces of code that, you know, really define a subgraph, and they're the manifest, the schema, and the mappings. And so, you know, there's a lot of stuff here that is definitely worthwhile to read, and I'm going to go over a lot of it in more so of an example. But, you know, we're going to skip straight to the subgraph manifest right here, which is really like the instruction manual for a subgraph. And how it works is, you know, if you look at all the blockchain data in the world from every single blockchain, Bitcoin, Ethereum, all of them, and then what we're trying to do is like compress it into a specific subset of data that you as a subgraph developer wants to look at. So if you look at, that's essentially what the manifest does. So if you look at this file right here, it's doing a few things. It starts to identify data sources. Okay, so that's the data that we're going to ingest into the subgraph. What kind? And this is an Ethereum contract. So already we've decided that it is the Ethereum blockchain and it's a contract. And now we've also defined that it's going to be from the mainnet Ethereum blockchain, as opposed to Ropsten or Rinkeby or something like that. And then we keep going down even further, and now it's, okay, what's the source? And it's this address that's on chain, 0x2e6, and we start indexing it at this block. And so what we've essentially done there is, you know, we've taken all the possible Ethereum networks that, all the possible blockchains that the graph can index. And we've decided, okay, just gonna go with Ethereum, just gonna go with mainnet, and we're gonna go look at this specific smart contract on the blockchain. So that's how far we've narrowed it down. And now we can narrow it down even further and look at specific handlers or specific events on that blockchain, and then write handlers for those. So we have these things down here called event handlers. And if you guys are familiar with Solidity, Solidity contracts can emit events, which are essentially just objects of data that get emitted, and it makes it easy for people external to the blockchain to consume and understand what happened. So events are used very frequently when you're designing a subgraph, because most of the time a smart contract developer will create events that emit the important information. And usually you can build a subgraph from just using event handlers. Sometimes though, there might be situations where you need specific information from a call handler. So this would happen when a specific function is called on a smart contract. So in this case, they're saying the create gravatar function. And so maybe when that function is called on the smart contract, the event that gets emitted when that function runs didn't have all the information you needed. So in some cases, you're going to have to just actually run a handler over top of when a function gets called. And so what's happening is we're tying, the information we want to pull from this specific contract from function calls or events that are emitted. And then when we get that specific data from that event or that function, and then we can store it into the subgraph. And the subgraph is essentially a database that it stores all this information from the blockchain and organizes it in a way that you want to organize it. And so as you can see, we've just been able to really, what the subgraph manifest lets us do is pinpoint the exact type of data that we want. And that's what's so powerful about the subgraph manifest. When you look at a subgraph, if you want to go explore some of the existing subgraphs today, like the Uniswap subgraph, or even like any Chainlink subgraph that exists, you would want to look at the manifest first, because it's going to be the most straightforward way of telling you what information this subgraph is grabbing from blockchains. So once and if you're a subgraph developer, it's probably going to be one of the first things you figure out and define. Like you're going to be looking at Chainlink smart contracts. You already know, you almost have your subgraph manifest written. You might have to find the specific smart contracts that you want from Chainlink. There could be maybe 3 different smart contracts on Ethereum mainnet that you want to get the data from that are all part of the Chainlink protocol. So then this manifest would have 3 different source files, right? But essentially, yeah, if you know what you want to index, that you can pretty much build your subgraph manifest very easily. Now, the next part that is worth getting into is the GraphQL schema. And so, we've defined what data we're getting from the blockchain, and what the GraphQL schema really does is it allows you to define how you want to store that information in your subgraph, and the order of how you want to store it, if you want to add any rich information to it. And, we can look at this example down here to see what exactly, a GraphQL schema is. And this is a very simple entity type. It's basically, an entity, an object, whatever you want to call it, but we're naming this type gravatar. And so gravatar is an example. It's a super simple smart contract, and we're actually going to use it for the example that I'm doing today. And we'll see how it ties into the subgraph overall. But we're storing this entity in the subgraph, and it's basically an entity or an object with 5 fields. One being a unique ID, which every single entity in a subgraph needs. And then there's 4 fields here that are determined from the subgraph or from the smart contract itself. And likely these are emitted from events. And so you'll have the event emit something like an owner, and that's going to be an Ethereum contract or an Ethereum address. It's also probably going to emit a display name and an image URL and whether or not it's been accepted. And so when we get that information, we're going to store it with mappings, and you'll see that very soon. But essentially, what the GraphQL schema is it's a pretty straightforward kind of way to store information. And GraphQL is something that was developed by Facebook and has been around for multiple years. And there's actually a lot of documentation on GraphQL external to everything. We're giving a little bit of information here, like the supported scalars that we have, but there's a lot of GraphQL information out there in the world that you can definitely dig into and learn about, the proper syntax and the proper best practices to follow when using GraphQL. And there's more, information here. We have relationships that can be, written into the schema, and reverse lookups, so it makes it easier, because at the end of the day, the GraphQL like interface that we build on top is connecting to the subgraph, which underneath is actually a Postgres database. So this is all interesting stuff that you don't really have to understand completely if you're designing a subgraph, but it is like kind of the important details of how it works underneath. And so and then after that, this is also part of GraphQL, is the queries that you have to write in order to get that information from the subgraph. And you saw that in the playground that I showed earlier, where there were just example queries for like the Uniswap subgraph and the other ones as well. So that's all really useful information. It keeps on going. I invite you to read more about all the documentation here if you're going to build a subgraph. But the next important thing to share is writing mappings. So, at this point, we've used the subgraph manifest to get the specific data that we want from all the blockchains that can be indexed. And then with the GraphQL schema, we've decided how we want to organize that data. The last major thing to do is to write the mappings. And what mappings are, they're essentially just, whenever an event is triggered on, or event is emitted on chain, one of these mappings gets triggered, and the mappings are doing, it's basically mapping over the information that's being emitted from the event and storing it in the subgraph somehow. And you can see it here. So these are all written in TypeScript. And so if you want to be a subgraph developer, mainly you need to understand TypeScript and GraphQL. It would also help to be able to read and write Solidity, but Solidity is it's not that complex of a language to read. So even if you can just read Solidity, you can be a subgraph developer as well. And you don't have to be, a prolific Solidity developer. So that's really good news for anybody who just, understands GraphQL. And even if you just understand TypeScript or JavaScript, you would be able to, make good progress on a subgraph, because a GraphQL schema could end up being very simple if you're just building a simple subgraph. And so what these mappings are doing, there is an event called new gravatar that is being emitted on chain by a smart contract. And there's this handler that gets run. And what this means is whenever this event is emitted on chain, this block of code is going to get run. So we're going to create a new entity, which is the gravatar entity, give it its unique ID, and we're going to set these 3 fields that belong on the entity. If you remember up in the GraphQL schema, these were 3 of the fields that were required to exist on the entity. So what we're doing is we're setting the owner, and this is simply an event field from the event that's emitted from Ethereum. And we do this for all 3 of them. We set the owner, we set the display name, we set the image URL. And then we store the entity in the subgraph with the .save function. And essentially right there, this is, a subgraph in a nutshell is a bunch of these mappings, running over and over again from block 0 to block 12 million or whatever Ethereum is at. Or whatever, if the smart contract that you're looking at was deployed on block 10 million, you're going to start there and you're going to index the next 2 million blocks that have existed. And over time, this smart contract exists on chain, and it's emitting events and it's emitting events. And every time these events get emitted, these handlers are run, and that's storing information in the subgraph, which is then available in the graph network and can be queried by anybody through the whole entire open API system. And there's a lot of information about, you might notice like the .save and all this stuff in 2hex. These are basically functions that we provide to help write the mappings, and ultimately the mappings are written in TypeScript or assembly script, which is a subset of TypeScript. And assembly script actually compiles down to WASM. And then these WASM files are uploaded to graph nodes, and these graph nodes actually execute all these function calls and run the subgraph essentially. And those are details you don't really have to understand. But if you're going to write mappings, you're obviously going to have to understand some of the patterns of like using toHex and, you know, using this kind of handler where if it's null, you're going to create a new object or a new entity. And all these details are really provided in here. As you can see, the documentation is very long. I invite you to read all of this. It's you know, we've been working on it for years and it's been refined very well. And so it's very clear and it'll help you build a subgraph. And if there's anything that isn't clear in the documentation, I invite you guys to come to our Discord channel where, you know, we have a ton of different channels here for people that are coming to, you know, learn about how to use the graph. And if you're doing a hackathon, you know, some of the channels that are really good to come to are the subgraph development one, the hosted service one, the hackathon one, and, you know, there's a few others that you could join in as well. And just come in there, ask us if there's any questions that you have, and, you know, ask the community as well. There's a lot of people who don't work at EdgeNode or who don't work at the Graph Foundation who are just part of the community who also help out a lot of the time. So it's a super vibrant community, and there's a lot of people who are, you know, happy to help out with developing subgraphs. And so what I'd like to do now is get into an example of developing a subgraph. And we can do that by going to the Explorer and, you know, clicking on, if you're in the Explorer, you're gonna have to create an account, which is essentially, you know, just linking your GitHub through OAuth, and then you get to your own account and you see all these past subgraphs you've made. I'm gonna create a new subgraph. And now you're on a page, you gotta give your subgraph a name. So I'm gonna name it Chainlink Hackathon 2, because I have one that is named Chainlink Hackathon from the past. And we're just going to give it a subtitle because it's required. And you can provide a description if you want and a GitHub URL. And you can also hide the subgraph if you want. This just means it won't be shown publicly. And so I'm actually going to hide this because it's just going to be a practice subgraph that you know, not too many people will be interested in. So I'm going to create this subgraph, and I've created it in the hosted service. And now you're provided with this page, and essentially it's created, but this subgraph has not been deployed to the hosted service yet. So what we're going to have to do is just follow the commands here, and they're actually very straightforward. So what we need to do is install Graph CLI onto your computer. We're going to do a global install. So you just copy it by clicking this button here. And I'm going to go to my terminal. And so I just paste that yarn global add graph protocol / graph CLI. And so this installs that. We go back to here. So I've finished this command. Now we go to the init command. And this is basically setting up a hello world subgraph that allows you to index data off the Ethereum mainnet. And once you have this set up, you'll be able to change your subgraph in order to index other data. And it kind of is like a really great starting point for anybody who wants to create a subgraph. And so now we have this information here, right? So this is how you basically start that kind of boilerplate subgraph. Copy that command. And now the directory I'm going to make is just called Hackathon. And now here I want to do the subgraph name, which is Chainlink Hackathon 2, which is the one that I just created. And now just my GitHub username. And this command will now be run. And it usually takes about 30 seconds here to set up the whole repository. So what it's doing is it's just generating a bunch of different subgraph boilerplate code that allows you to get a project started right away. And ultimately, this is, you know, the Gravatar example, and it's gonna be really easy to deploy to main or to the hosted service. And you're gonna see all this happen in the next, you know, 10, 20 minutes. And it's really good. It's really easy. And then what I'd recommend people do is take this exact process, do it, but then start replacing the files and the information with the specific information that you want to build your own subgraph, which could be, you know, using Chainlink or using Aave or using their contract, something like that, right? So now we have this folder built. If we look, there is a folder called Hackathon. And if we go into there and open it up with VS Code, you're going to see all these files here have been auto-generated, which is really great. And before we get into that, I just want to head back to the Explorer. And now it also wants me to run yarn install and yarn code gen. So that's actually really easy to do. Perfect. Yarn code gen. Perfect. And then the last command is to deploy, and we'll do that after I look at the smart contract code here and all the subgraph code. So now we're back in the, you know, this is the auto-generated file or folder that gets created on Graph Init. And now I'm gonna, you know, step through a lot of these files so you can understand what's going on. And you use this, you know, boilerplate code to build, you know, a more interesting subgraph that you're gonna use for this hackathon. And quickly, you know, I'm going to go over all the files that I just explained through the documentation. So this is the subgraph manifest that I was talking about before. And as we can see again, you know, we look at the data source. Okay, great. There's one data source. It's an Ethereum contract. We've named it Gravity. It's on the Ethereum mainnet, and it has this Ethereum smart contract address, and it has 2 event handlers. And that's pretty great. It's pretty straightforward. Some of the other stuff I haven't talked about before is, you know, this ABIs thing. So every single smart contract on Ethereum has an ABI associated with it. And what we're doing is we're connecting this ABI to the subgraph. And an ABI, you know, essentially contains all the event signatures and the function signatures. And it's all kind of like, you know, messy right here. But I can organize it like that. And you see it's a little bit more of an organized JSON file. But you just have to get in the ABIs for any smart contract that you want to look at. And that's when some of this code gets auto-generated. So, you know, that ABI helps us create this generated code. I'm not going to get into that here because that's code you're not really supposed to touch. It's just auto-generated, and you use it in the mappings. But yeah, let's look at some of this other code here. So we've kind of described the manifest and how it works. Here's the GraphQL schema that I was talking about before, right? So right here we have one entity called Gravatar, and Gravatar is just like the smart contract itself is just kind of like a, you know, an object that has an ID, has an owner, has a display name, and an image URL. So it would be like, you know, a little circle that you see in you know, a website somewhere, kind of like an account, right? Like similar to this, like you have your face and maybe like your name. That's all Gravatar is trying to do. It's just trying to be a simple way to represent like an account. And so that's all this GraphQL schema is doing. It's really simple. You know, sometimes you might see a subgraph manifest that's a couple hundred lines long. A subgraph schema could be a couple hundred lines long. And then what you're going to see in a little bit is the mappings can actually be thousands of lines long for really big subgraphs like Uniswap. And we'll get into that in a second. But yeah, that's the subgraph schema and the subgraph manifest. Then I'll quickly go over all these files you see here. You know, these are basic just project files like, you know, git ignore, package JSON, license, readme, truffle.js. None of these are super important. If you understand, you know, a little bit of Ethereum and coding, you'll get all this stuff. If we quickly hop to the contracts, these are just Solidity code that is, you know, this is basically the Gravity smart contract or Gravatar, right? And, you know, it's only 60 lines of smart contract code, really easy to understand. And that's what I've said before, like, you know, Solidity isn't that hard to read. It's hard to write securely, but if you're just reading it and you're not a Solidity developer, you can still create a subgraph. And so as you can see, there's these two events right here. And these events just emit simple information. It's a new gravatar and an updated gravatar. They both have an ID, they both have an owner, they both have a display name, and they both have an image URL. And we're going to take that information that's emitted from the blockchain, and we're going to store it in the subgraph by using our mappings. So now if we hop to the source folder, you can go to the mappings, you're going to see we're importing the updated gravatar and the new gravatar events. Essentially, these events store those 4 fields that we saw, that information, and these are auto-generated from the ABI. And then we're also importing the entity gravatar that we created in the schema. And so these are both generated files. You would have to make sure you import these in your subgraph, but it's pretty straightforward. And now you just start writing, basically TypeScript functions. So whenever this function, new gravatar, or this event, new gravatar is emitted by that smart contract, we're going to run this function. And we're going to do a new gravatar or save a new gravatar. We're going to store these 3 fields on it. And then we're going to save it into the subgraph. And it's pretty straightforward. I've kind of described this mapping before, and you can see both of these are very straightforward. And it's just a very easy subgraph to understand. But as I was describing before, these can get thousands of lines long. And when you think about a subgraph, there's a couple different things you can do. You can store the live data that's on the blockchain, whatever is the most up-to-date information, or you could also store historical data on the blockchain, right? And maybe I'll show an example of that later on. But when you're storing historical data, you might store the amount of trades that happened every day, on how much volume happened, and how much volatility there was, and all this really interesting information. And that's actually what's so powerful about subgraphs is you can really take any data from the blockchain and create very rich subgraphs that have all this complex data that really make it a lot easier for humans to understand what's happening on the blockchain. And so now I've described all the code in this repository, and now I want to hop back and just deploy this subgraph. So as you can see, you got to authorize yourself, and you just run this command, graph auth, and you delete the placeholder access token and use your access token that's given to you in the Explorer. And so now I am authorized. And then we're just going to deploy the subgraph. So I'm going to copy that and replace the subgraph name with the one we're working on. And that's getting deployed right now to the hosted service. And it's done. So if we go back here, and as you see, the page already refreshed, this subgraph is now deployed to this endpoint in the hosted service. And so if you go down, an example query is auto-generated for us. And if we just click that, we'll see all these gravatars that have been created on Ethereum before. And there you have it. There's all this data on the blockchain. We went from all of the possible data on the blockchain, and we've basically condensed it into just this one single smart contract on Ethereum and a couple events on Ethereum. And now we've created an open API that anybody can query and get this data back. And what's really interesting about the whole entire graph network is all this stuff is done in a deterministic manner. And any indexer around the world can index a subgraph from scratch by just downloading all the manifest files and everything. So if you have this file, right, the manifest and the files that connect to it, the mappings and the schema, you can then build a subgraph from scratch. And now you have this system where there's open APIs all around the world that anybody can join in and participate in the network and start earning query fees in the real network and build this amazing kind of open network that anybody can participate in, that powers DeFi, powers all these other blockchain applications that exist. And that's what's so, interesting about the graph and what makes it so powerful. And so that's kind of like high level, an example. And now I want to show an example too of just how Uniswap works. This is probably one of the most used subgraphs. Everybody knows Uniswap. There's so many transactions that happen. As you can imagine, this subgraph takes a long time to actually index. Like there's 76 million entities that are stored in this subgraphs database, which is a lot. And so if we quickly go to the code here, if this is a subgraph that is public, it's the Uniswap B2 subgraph. If you look at the schema really quickly, there's 300 lines here, right? They're storing a bunch of historical data, like the price data for a token, for a specific token pair. We're doing hourly volumes and daily volumes, and then we're kind of also aggregating the entire Uniswap volume, total USD volume, ETH and USD. So that's there might be a couple thousand trading pairs on Uniswap, but there's no way to see the total volume that happens in a day just by reading the blockchain and querying an Ethereum node. It's just way too complex. But when you have a subgraph that's running over top of every single event that happens in Uniswap, it can basically index all this information and return that information to you in a very rich way. So if you go to uniswap.info, this website is basically run off of a subgraph. And so all this information you're seeing here, all this rich data, this chart data from last year, May, up to here, we're seeing how much the liquidity has increased over time and then decreased and increased. There's probably millions of different handlers running over top of all the Ethereum events that happened in the last year and a half here. And you're seeing really interesting stuff. And we're even calculating the volume, right? So these are usually, you wouldn't be able to get this information just by looking at an Ethereum node, but it does exist. And now all of a sudden with this information, you start to get a DEX like Uniswap that has rich information that a centralized exchange could provide, right? Like CeFi, and you start to have DeFi starting to look like CeFi. And really that's what we've seen in the last year and a half is DeFi really taking a large portion of users, capital and liquidity. And if you even click on something like USDC, you get specific information for this token. You get the total volume that it's had, the total liquidity. The price obviously is going to be pretty close to 1 because this is a stable coin. But yeah, this is what can be built with the graph, and it's the sky is really the limit. So for the hackathon, we're really excited to see what people can build, and we love to see somebody build with Chainlink. Once again, I'll repeat the 5 prizes that we're looking to see: the best subgraph using Chainlink oracles, the best governance subgraph, the best DeFi subgraph, the best NFT subgraph, and the best Web3 subgraph. So each of those subgraphs will get $1,000 for a prize, and we're super excited to see what everybody builds. That's pretty much all I have to say today, and I'd stop the presentation here and open it up for questions that people have.
Awesome, thanks a lot, Dave. Yeah, when I first got into web development and I started learning about GraphQL, I was like, holy shit, this is genius. Why hasn't SQL always kind of been this way, SQL? And then heard about the graph on Web3, and I think that's where people, they're like, wait a minute, this didn't exist before, it's just something that is so needed, and what you're saying just makes all these applications on Web3 really come to life, and I think that's so amazing about what you guys are working on. We have some really good questions here in the chat that kind of came through, and appreciate everyone's good discussion here about this. The first one, I know you guys have been hard at work, and it seems like every single day there's another blockchain. Are you guys on, can you use the graph on Solana?
I am not up to date on whether or not that actually, I don't think it works right now, and I'm not even 100% sure personally, because I'm not always on that side of the team of if we're integrating or not. But as far as it works, it's like really what the community wants is what blockchains we're going to add. And from what I've seen, I think Solana is been in high demand, and I have a feeling that, you know, Solana blockchain will be indexable by the Graph. But if I'm pretty sure it's not right now. And the part of that reason is for a little bit more technical details. It's like any EVM chain is really easy for us to index because that's what the Graph started on, right? So if you look at something like Phantom, we just have to change a little bit of configurations and we can index that chain. Solana is a completely different blockchain. So we're going to have to write, you know, this core code from the Graph node, which is all written in Rust. We're going to have to add some, you know, a bunch of new code to index that blockchain. So those kind of blockchains like Solana and Polkadot, they just take longer for us to do. But, you know, all those blockchains are like, you know, on our roadmap in some way. And we're hoping to basically query, or we're hoping to index basically every single blockchain that, you know, people want.
Cool. Yeah, no, another one. Are there other data sources or indexing triggers planned with the Graph, similar to Chainlink's initiators, where you can trigger a cron job or webhooks? Is that something that's possible with the Graph or planned?
Yeah, that's interesting. It's a great question. Like, I think there's a lot of research there that could be done. Like there are specific things right now. The Graph only really reads data, right? Like all that stuff that I showed you here, it's reading data off the blockchain. There are plans to add mutations to the Graph, which would essentially be, you know, you can write directly and do function calls through a subgraph. So instead of like, you know, if you're a front-end developer, you might have to write basically code in like this wrapper code around, you know, using ethers.js and hit smart contract functions in order to have people like execute transactions on chain. If you've used any DeFi application like Aave, like Compound, that's basically what it's doing. Some front-end developer wrote the code there, and you know, now you hit the subgraph, or now you hit the Ethereum chain and you did a transaction. Now, what mutations are is basically like putting it all behind the scenes in a subgraph in a similar way we've just seen how we index everything for you, and it allows the API to be used very easily. We could have mutations work, so you just hit a subgraph, and maybe you're going to do a function call in Compound to put more USDC in the protocol to earn more income. And instead of having like 100 different front-end developers around the world write that code custom, you just hit the Subgraph API endpoint and give it the parameters that you want to give it, and it's going to submit it to a blockchain. So that's really cool. And when you think about it, like that enables a lot of possibilities.
Yeah.
That would allow like these hooks that can be done. And we, like the Graph Foundation, is also thinking a lot about like event hooks and like, you know, pushing notifications to people and getting, because that's kind of hard to do right now, right? If you had a subscription that you were paying for, something like Sablier, or even if like, you know, you start getting your Spotify subscription on chain somehow in the future, and you need to top that up, like nobody's going to email you right now because it doesn't work like that. But the Graph is like really thinking about how can we get that set up so like a subgraph could do that automatically.
Yeah, that'd be fascinating. Yeah, that'd be really cool to see happen.
Yeah, excited to see that.
Yeah, I know. And your team's grown like crazy, right? Do you guys hiring any specific positions, at least on your team, that you know of, or anything for the hackers and other people that are listening in for jobs and careers?
For sure, yeah. I might as well go to the jobs page right here. We have a lot of open positions. Some of these, you know, we've been growing like crazy. I think we've hired 10 people this year, and we were probably a team of 17 or 18, and now we're probably 28 or so. We've hired a lot. Like I'm on the smart contract team, and we still are looking for a Solidity engineer and like a software engineer. Software engineer being somebody like who knows a lot of TypeScript, right? Who understands blockchains but might not necessarily know Solidity. So yeah, we're looking to grow the team. It's only 2 of us right now on the smart contract team, and that's definitely somewhere we need to hire. And there's still other positions here, but I'm not too up to date with them. But I know there's a UI designer we're looking for, and then a couple others for sure. So we're 100% looking to grow.
Cool. Awesome. Yeah, a lot of room to grow and exciting times. Dave, really appreciate you coming on here. I know it's your birthday next week, so happy early birthday. And yeah, really
Thank
appreciate
you.
Tegan and everyone on the Graph team for everything that you guys do.
Awesome. Thank you so much.
Cool. Thanks everyone for listening in. If you have questions, definitely hop into the Graph Discord as well as their section in our Discord. And we'll see you soon.